IIC Bangalore. Sir, please.
তখন জানি না
আচ্ছা,
আরেকজন যদি আসেন কিছু পেয়েছি এখানে থেকে
sir, please. So very good morning. This is the second lecture, second keynote lecture to Sudhan Majhi. So before his lecture, I am just introducing Professor Majhi. Professor Sudhan Engineering at the Indian Institute of Science, Bangalore. He holds a PhD from your City, NTU, Singapore, and MTech from Singapore, and MSc in Applied Mathematics from Vidyasagar University, and a BSc in Mathematics from Mednagar College under Vidyasagar University, the full Institution of Engineering, fellow of Institution of Electronics and Telecommunication, IT, and senior member of University. With academic and international research, Professor Majhi made significant contribution to wireless communication, signal processing, artificial intelligence, and machine learning for 6G communication system. That one is coming in near future. Configure internet service, orthogonal frequency space, integrating sensing and communication, estimation and detection. He currently serves as an editor of several important journals are IEEE Transaction and Communication and IEEE Wireless Communication Letters. This is very prestigious journals and has led several by defense organization, government of India, and industry partners. His research interests include 6G, for office communication, MIM, TFS, RIS, ISAC. I don't know the full name of this because it is related to electronics. But it's electronics area, electronics related field communication, estimation and detection, and physical layer security, etc. Professor C, now as your full profession, and before joining the Sudhan faculty of IIT Patna, research fellow at NTU, Singapore, research scientist at INSA, France, and postdoctoral fellow USA. He has also the visiting position at the institution Taiwan, Australia, China, and UAE, and also USA. Professor Majhi is investigator or co-investigator for 27 sponsor research project. This is very high your figure. With 15 rupees 15 crore from organizations such as your DSTSRB, and many Indian and foreign your funding agencies. He also accepts the assignment from leading industries including Tejas Network, Samsung Semiconductor, and many others. Many more than 6-7 organizations. His scholarly activity comprises more than 130 journal publications in prestigious IEEE Transaction and other leading journals. A Springer book and several granted patents related to AFDM and OPFS, your modulations. modulation classification and communication system. He has supervised 30 your completed PhD scholar, 7 ongoing PhD students, 15 completed MTech student, 2 ongoing MTech, and 16 BTech projects under his supervisions. In addition to his research accomplishment, Professor Majhi has held several editorial and leadership roles, including the editor of IEEE Transaction and Communication, IEEE wireless communication letters, etc. Lot of IEEE journals you have editing. Okay, with these few words, I request Professor Majhi to deliver his lecture. So see that your background is very strong, and we are very proud that Professor Majhi is the ex-student of our department of mathematics, applied mathematics department of Vidyasagar University. So again, congratulations, Professor Majhi. So based on his research activities in the field of mathematics as well as your electronic science, so as per the recommendation of the organizing committee and academic committee, so we are announcing that Professor Sudhan Majhi is confirmed Research Excellence Award presented by your Vidyasagar University, Dibrugarh University, and our society SAMS.
Hello. Hello. Good afternoon, everyone. My sir, Professor Madhumangal Pal, introduced very fastly my research career. So I'm a bit proud. I feel always proud when someone say that I'm masters and graduate from Vidyasagar University. Okay, so that is always I feel that I'm proud, and always whenever I get some invitation from here, I try to come. So I occasionally come as a resource person, as a invited speaker, or as a keynote speaker. I hardly said no until now, unless otherwise if it is a committed for any other work. So let me come to the today's talk. That my talk is a bit offside than the mathematics, because you have seen that after my masters I did most of my work in wireless communication, electronics and communication, and most of the time when I visited Vidyasagar University, I always try to give some kind of different kind of talk. Okay, I never find that I have given any research talk. Okay, so today I thought, before accepting this offer, I thought let me give some kind of research work. But then when I found that this is intelligence, artificial intelligence, I work heavily on artificial intelligence, but mostly the work is related to wireless communication. And since most of the audience are not from that background, so it will be very difficult to explain the things. So that's the reason I have chosen another research field, mathematics, but this mathematics applied in the wireless communication. And I think 10 or 12 PhD students from mathematics, they are pure mathematicians, but somehow I trained them that how to apply some mathematics to the wireless communication. So before going to this talk, I just want to show some overview that why this mathematics topics I have chosen. So You can see that MIMO, this is a multi-user MIMO. You can understand this is a tower, right? Our base station. And that is a two users, mobile, our mobile. So they connecting, there is a different tower. You can see if these two mobile device even close each other, they can be served by two different links, okay? At the same time, at the same frequency and same band. So then when we communicate to two users simultaneously, there should be some collide, right? Means like the same communication can be happen to two users. But when you see that when I call and you call, there is no interference. There is no miss. So we separately call. How we do? Totally mathematics. So what mathematics we use? So this channel is kind of, so this is a one kind of channel and independent, but they are not orthogonal. So what we do, we find a proper matrix or precoding vector. So this precoding vector, we multiply such a way that they become orthogonal. So that's why when they communicate to this one gets 0. When they communicate to this one gets 0. Now, this designing precoding vector is a game of mathematics. So for when number of antennas 8, 10, that's fine. But when number of antenna goes 32, 64 by like 5G or 6G, so that time we find very difficult to make a sequence design orthogonality. So I'm giving one example what difficulties it is. Let's say if I ask you, can you please give me a two orthogonal vectors? You can easily say, okay, 0, 1, 1, 0. They are two orthogonal vectors, right? But if I say three orthogonal vector, you can say, okay, 0, 0, 1, or 1, 0, 0. Three vectors you can easily get. But if I ask, can you give the vectors of 100? Then you cannot do. Even if you give the computer, it may take 1 day, 2 days, even 1 month. If I say, okay, 100 users, 1000 users, can you give the orthogonality vectors? Computer cannot do. So why computer cannot do? Because this is some kind of random search. And random search takes a lot of time. So then, but if I tell, okay, there is some restriction, okay, the first element will be 1, then second element cannot be 1. So if this is called the kind of, I'm giving some instruction, it's a systematic construction. Then I have to give such a huge instruction. So that is also complex. So now then we found, is there any not other way to resolve this? Then we brought a generalized Boolean algebra. So this generalized Boolean algebra or generalized Boolean function, so that I worked for the last 15 years, and in our group, we were so dominated at that time that whatever the open problem we had, so almost we solved 50-60 open problems. So making this sequence design the orthogonal. Okay, so now because now there are a lot of work pressure from the wireless communication, from the defense. Now I heavily involved in the defense. Okay, and defense you cannot say because in India might be 2 to 3 people who work on defense. Okay, so defense communication. So they are the defense, and sometimes instruction come from the ministry. I have to deliver something for the Indian defense, Indian army, Indian navy. So that's the reason I had to restrict this now. This kind of mathematics, but still I am having 2 to 3 postdoc, so they are working this direction. So based on this work, I'll be giving very basic, okay, but totally different domain, but it's totally mathematics. So regarding this, and okay, then that is the design of some generalized Boolean function. So recently, some of my students, what they have done, they generated this code by using ICAMAIA. So that part I'm not giving, but I'm saying that what is the importance of AIML to come to this picture. This is a 6G wireless communication which will be launched in 2030, and I'm representing India. So we need to, there is a different countries. So we made a group. It's called 3G people. So this 3G people, what they do? They design that what kind of specification will be your mobile. You can see that you go with this mobile to US, Europe, or any other countries, you will be able to communicate. But think about 10 years back, or not 10 years, 20 years back. So if you purchase a US mobile phone, it never used to work in India. Okay. Okay, but then how? Now, because this 3GPP committee, they said, now whatever the mobile specification will be there, it should be uniform. Okay, so that makes 3GPP, and then they bought. You can see that one of the this is okay. So in 5G, this is not there. Okay, 5G only this green line, green. This one was 5G. This one was 5G. This one was 5G, and these are coming 6G. So AIML, what I said, this designing, estimation, detection, all the mathematical work now being done by AIML. Like designing code, now we are applying AIML. Estimation, detection, many things we are doing AIML. So let me tell you these three, what is this one? One is AIML, the other is that currently you can communicate to cellular, Wi-Fi to Wi-Fi. But let's say I'm having only Wi-Fi device. Can I able to connect to cellular system? No. But 6G we are trying to, that satellite, our mobile will be connecting to not Wi-Fi, there is a not Wi-Fi transmitter, satellite transmitter, only one transmitter will be there, that will be connecting to different things. That is the things one. Integrated sensing is a very interesting topic. So now you see there is a TV view, view count when you see the TV, the right hand side, the right view count. So this view count is not original. Why? Because one TV is connected, then it will be count one. But one TV, how many people are watching? We do not know. It may be 5, 6. So the original count should be the number of people watching this TV, right? So now we are making a mobile device, or let's say there will be TV, there will be some kind of sensor. That sensor will count even how many users are watching. So this is called the integrated sensing and communication. So why I'm putting this one? 2030, and we are working for the 2020. That what could be the 6G that we are working, and now in the middle of the stage. So 2030 we'll be launching this 6G wireless communication. So now let me see that how mathematically we design code and how those code can be designed by AI. So last part I may not be able to cover, but I'll be giving some basic overview of So some basic, this is an outline that correlation functions, I think you know, but you know different way. You know autocorrelation, cross-correlation, you know, right? Mathematics, guys? Or statistics. Okay, so correlation, autocorrelation, I have to understand a little bit, otherwise I cannot able to proceed. I'll be giving very basic things. You have to understand what is GBA, generalized Boolean function, and we have to understand that how directly we can construct and how by systematic search or computer search we can construct. As I said, by the computer search, it may take 1 year, it may not be possible. Systematic, it can take 1 month, 2 months, but generalized Boolean function is a matter of milliseconds. So, matter of millisecond. So that kind of, we have developed a mathematical model that if you give some instruction to your function, the function will give whatever code you need. So that is the beauty of GPA. Now, let me discuss a little bit correlation. So this is a priori cross-correlation functions. By seeing the mathematics, you are saying, okay, this is very difficult. It's very simple. You take a vectors, you take another vectors, you shift, multiply, shift, multiply, then add. So when you are shifting, we are not adding those in the back. So this is a priori. You add the whatever the shifting extra is coming. If you shift to the back, that is the priori correlation. So this is the a priori correlation, and this A0, A1 is element of vector. A is vector, you understand. B is another vector, that also you understand. And B0, B1 elements. Now we have to do the code. Cross correlation. Cross correlation means A, B are different. If autocorrelation means A, B. This is the two definition. Now I have given a simple example you can understand. So shifting tau equal to 0 means no shift. So that is some kind of correlation. And then you just multiply, add, then whatever value will be getting. Tau equal to -2 means you just shift 2. Then you multiply. You can see that A0 and A0 will be multiplied, nothing but 0. A1 will be multiplied 0, but B6 and B7 also will be multiplied. So you will be getting contributing vector from the A to A7. Now tau equal to 2, just shift the left, B1. Why B1, B0, B1 we are making conjugate? So these are the complex. It's not just vector means 0, 1, 0, 1. This could be a complex number. That's why we are providing. Now, by this using this cross correlation, autocorrelation, we can define. So mutually orthogonal. Let us now we have to just understand correlation, autocorrelation, cross correlation, and vector matrix. That's all. Then we'll be able to understand the next 4-5 slides. Okay. So S1 is a matrix. A1 is a row of the matrix. A2 is another matrix. P another matrix, and there is a first row, second row, third row. Now we have to do the correlation. How we do the correlation? Oh, now it's fine, no? So S1 is a matrix. A1 is a row, first row, second row. Now we have to do the correlation. How do we do the correlation? You can see that A is a we know what correlation. Take one row, take another row. They are vectors. Now you do the correlation. That capital A is nothing but a autocorrelation notation. AI is a ith row of A matrix. BI is a ith row of the B matrix. Now if you do the, because these are the two different matrix, that's why we are denoting C. So C is what? C is nothing but a cross correlation. Why cross correlation? Because they are two different matrix. Now tau is what? You can shift the tau equal to 0, tau equal to 1, tau equal to -2, -5, we have shown, right? And we have just taken matrix S1, matrix S2, and we have done the cross correlation. Now when we can say this one as a mutually orthogonal code, if this property fulfills, you know, if we take a matrix and then if we do the autocorrelation sum, so we take one matrix AI, all these things, and then take another all the row, and then if we do the autocorrelation, all these things, then you can see that we'll be getting LP at tau equal to 0 and all other 0. So you can see that this diagram, you can see that only tau equal to 0, their value, and for other shifting, it is a 0. And it is a very good property for the communication. You know? So when we transmit some power, you know, so you can see that when we can transmit power, let me tell you that if we transmit a power very thin, that will happen, it will burn, right? Then we need to transmit more power, then we need a very big wire, right? So similarly, when we transmit power for 1,000 people, we are communicating from the tower. If we do not design this antenna properly, no, so this will be, the entire antenna will be melted because too much power you are generating. So then we have to restrict that power should not be very high. So power should not be very low. So that Bole complementary code we design such a way that the power will be not going very high and not will be going very deep. So there will be some kind of things. Okay, so this Bole complementary code play a major role when we transmit base station power to the mobile. Similarly, mobile to base station. Okay, so this is one application I said. Now I am giving one example. Then you will be able to understand what is DCS. So A1 is a one matrix, and A1 is a one vector, first row, A2 second row, A3 third row, and A4 fourth row. Now you can see that just I am playing tau equal to 0. Tau equal to 0 is the 4 length vector. Obviously it will give 4, right? Autocorrelation,
because we have this plus means plus one, minus means minus one, minus minus will be plus, plus plus will be plus. So always if the length is n, the autocorrelation value will be n. You can see it from here, but this will be only tau equal to 0. So tau equal to 0 we are getting 4, and tau equal to 1 minus 3, tau equal to 2. So we have calculated autocorrelation of A1, A2, A3, A1, A2, A3, A4. Now you sum up all these things, you see the beauty. Okay. Now, if I ask someone to, can you please design with this 4 matrix? Yeah, if you spend one day, you can able to do. But if I ask you to, can you please give me 100 such sequence or a matrix? If I do the autocorrelation and sum, it will be giving this property. You see, all other 0, only a tau equal to 0 is giving value. It's almost impossible by hand features. Okay. So now there is a problem that you design a mathematical model. Irrespective of the number, we can able to get this one. You know this importance of this one, but designing was very difficult. I'm talking about 2010, 2011. So that time directly constructing the such kind of code. 2010, 2011 it was good. 2002 it was very difficult. How difficult if you can understand the Reliance Communication? You heard Reliance Communication? So they are bankrupt. Why, you know? Because of nobody could able to design this kind of code. 2002, whatever the code availability, they are minimal. And when the communication came, so Reliance industry thought, okay, currently one town, how many people? Maybe 5. Okay, in future, how many people can be participating? Maybe 50. So that was their measurement there. That is the plan. But suddenly in 2002, 2004, 2005, suddenly instead of 50, 100 people came to the market. And what was the technology that time they had? Technology means this OLE code or CDMA code or Walmart code. So those code was limited to 32 only. They could support only 32 users. So, and no, that time nobody, no researcher could able to find the code which can support 100 users. So now you understand Reliance Communication what happened, right? So technology play a major role. Now again we are rebuilding, we are coming, but as that awareness when they had no. So when we designed this code in 2015 and 16, then at that time I approached to many industry, all industry said, no, that you know the history of Reliance, right? Do you want us to? I said, we have designed the code, we have solved this problem. So it could support 1,000, 1,000, that is not an issue. But nobody could. Even when I moved to ISC, I approached to at least 30, 40 industry that please take this technology because we had patented those technology. But then suddenly I made a CTO of Bell Technology, and by seeing this one, he said, because the cellular system, mobile communication, these are the consumer. The consumer is very big. Nobody could take a risk if there is even 0.001% of failure. Okay? Because once failure, they call. So now I am designing this code for Bell Technology. So Bell, because they no need to sell to the consumer. They have to sell only to the defense and military. So what happened? They have taken this code. Now we have developed what we developed. So currently some limitation. I'm just not sharing little bit military, but in an academic point of view. For example, at this point, if we want to launch a missile to attack some enemy people, we can maximum launch 6 at a particular type of missile, we can launch maximum 4 to 6 at a time. But you know also that at a time, if you could launch many missiles, then we can attack, then whatever the air defense system the enemy people has, they may not able to, if we 100 launch 16, 17, they may not able to destroy by their air defense. Okay, that was the technology. So now we have designed at a time 16 missile can be launched. Missile launched, what is the relation with the communication? Because missile launch is, so I was also thinking before, okay, this Ogni is going 300 kilometers or 300 kilometers range. Why they cannot make 600? Why cannot make 1,000 kilometer range? The problem is not about the fueling, that you give the more fuel and you launch and it will go, not like this. Every time the missile has some communication device. They communicate to you. They give their position. They give the direction. They give each and every tracking. We need to communicate. Okay, and when the range is 300 kilometers, the signal power is very good. You can able to receive. But when long distance will be, let's say 1,000 kilometers, that time we have to transmit more power. Our tower will get melted because we do not have that much of capacity to transmit the power. Okay, so now, so then you have to receive those signals. Okay, so and then when multiple users know, they do not have a orthogonality. So orthogonality means, as I said, synchronization. You have to understand tau equal to 0, tau equal to 1. Only tau equal to 0, we could be able to get the signal. Other value, right? So making synchronization again a very, very important task. So this synchronization, how you can handle? There are many ways to handle, but the main point was that they become a orthogonality. Orthogonality cannot be maintained. Because you can say, because like 10 years or 5 years back, when I started to discussing with the defense, I designed some system model and they given a huge fund. So then I presented the first meeting. They said, no, the code is essential. Two launcher, they are having the same time. I said, yes, possible. What is the problem? They are connected to the internet. How they will be connected? I said, internet. Then how they understand that they are same time? I said, okay, GPS signal, GPS receiver is there. They said that during the war, who is going to give you the GPS? Okay, so US, let's say you are fighting with US. Do you think that you will be able to access the GPS like our Kargil war? Kargil war had the same issue. Kargil war, we could not able to access the GPS receiver. That was our problem. We could not able to fly our fighter plane. So that was the major issue. So I'm just giving some practical things and then how we are solving mathematician. Okay, so this was one problem. Now we have solved 16 missiles can be launched. Okay, and that almost completed the project. Okay, and from my part, even it is not that initially when I moved to ISC, that time I know how to develop algorithm, but how to put this algorithm in a hard disk or hardware. And Bell said, sir, if you can give the code, fine, but when we'll be designing, we'll be facing the problem. Can you able to design this by yourself? I said, I'm totally researcher. I cannot do. They said, sir, you try. I can give you fund. How much fund you? Okay, I can give you fund because that this algorithm how to run in the FPGA board. I said, I'm totally new. Then last 5 years, I developed a team, and now we are designing a complete system. So, like the mobile system, you can see this will be not small mobile because this is chip design. We design a little bit bigger size because mobile need a chip because you need to sell to many people. But SDR, we call the SDR software defined radio. That how many need? Only 10 or 12, right? So we can design a FPGA board. Cost will be like 1 lakh, 5 lakh something. So we have designed that, okay, and we have handed over to the deal, our DRDO. So I'm going to little bit offside. So GCP, now Gole complementary set. What is the Gole complementary pair? Just one matrix, there are n rows. Now we are taking 2 rows, okay, and GCP. And this all mobile communication, the GCP chip is inside your mobile. Otherwise, you cannot communicate. So there is a GCP code, there is a ZCZ code, there is a ZW code. So whatever the code sequence we are designing, each and every code will be deployed in our mobile device. Okay, why? Now to synchronize. You are sending some data packet, right? Whatever the electromagnetic coming. So finally you are converting them to 1010. You have to understand the starting point. That where is my frame is starting? Okay, so giving one example, then you can able to understand. Let's say a train is coming, you have to receive one parcel from Midnapur station. Okay, so train will not stop because you are sending the signal will not stop. So how do you receive the things? So if you are starting from here, you have to know what is your speed. I'm moving 5 km per hour. Okay, so 5 km per hour means when you move to this station and you reaching should be the same time because you cannot also stop. You have to also pause, right? So if you take the parcel so that this train is coming and you are going, that has to be exactly the same. If you little bit here and there, then train will pass, or either you will able to not reach, or you. So similarly, when we are receiving the signal from the base station, and when we are receiving, that has to be perfect, and that synchronization take care by this guy. So there is the correlation to find the peak. That is the matching point. So this signal is coming, and I'm also going. So that tau is a very, very important. If tau equal to only means not second, it is like nanosecond. If only 2-3 nanosecond is mismatch, not 1 millisecond. 1 millisecond is a huge amount time for us. In the communication, when you do 1 millisecond is huge time. But nanosecond, microsecond. So that kind of accuracy we need to bring to our pictures. So that is you can understand from there how the timing offset work. So these are some example I have given that how GCP works, and this is the another example of GCPs, and you can see that how we are getting tau equal to 0. Just one example I had given. Okay. So now there is a complete complementary code. Why do we need? Again, the story is that Walsh-Hadamard code. What is the problem of Walsh-Hadamard code? That 2002 technology used by the Reliance Communication, who supplied? Ericsson supplied. Okay, so you know that the fight between the Ericsson and Reliance. Okay, so that brought down this Reliance Communication. Okay, so that time they didn't have this CCC communication. What is the code? The code is orthogonal if they are aligned. Code are orthogonal if they are aligned. If the code is slightly left and right, then they are not orthogonal at all. So that we got a CCC technology. So CCC technology not novel, not we have developed. This is developed by other people, but they had some kind of constant. What constant they had? So they had a constant that flexible code. So code size could be length to the power n. But our group, what we have done, we make little bit flexible. That whatever the number of users, whatever number of capacity, it could fix to the system. So, so this is CC code. You can see that. Then there is many matrix, but here also a lot of Gole complementary set and CCC almost same. But what is the issue is that some number of row. So number of row is there very large. Okay, but in this case, number of row is very low, and that is some capacity that how many users you can support all these things. I'm not going to that direction, but this is a property. There are p number of sets. Sets means I'm talking about matrix, and they will be orthogonal if they are different, and if they will be orthonormal. Orthonormal means autocorrelation will be 1. If they equal to, this I equal to j means they are different, and then it will be 0. Otherwise, it will be giving 1. So again, I am giving one example. Two sets p equal to now 2. This is one matrix S1. This is S2. This S1 will be given to one users. S2 will be given to the another users. Okay. Now you think that so base station transmitting S1, then you may not able to receive the signal. So this is a call a code division multiple access technique. What code division multiple access technique? Three division. I'm sharing to use 3. One is frequency division, that different users giving 2 different frequency band. Time division, 2 different users giving them 2 different times. So one people using 1 millisecond data packet is receiving, second mobile using the second millisecond. There is time division. Another is code division. What code division? They are using different code. What kind of things? Let's say there is a table. You are sitting 4 people, and 2 people know Bengalis and 2 people know Kerala. Okay. Now, no. First, you 4 people are Bengali. Now you talk different matters. You may not be able to understand because all people are speaking, and there is a mismatch because you are able to getting the same kind of language, so you may not be able to communicate. But you replace 2 guys to Kerala people, okay? And now you talk. There is no interference. Coordination multiple access, okay? And that heavily we use 3G after 3G, 2G, 3G. 3G we used to this 2002, 2004. After that, now there is no 3G. System use this 3G, but all the military communication, either US, whatever the standard they have, most of the time we use this kind of code. Right? Now this code, when you multiply, no, So this is band. When you multiply, they like bandwidth become like this, So they are below the noise level. So if you do not know the code, it's a very difficult to intercept the data. But what about the cellular systems? Whatever you are using, we can easily track your data. We can easily, but defense is very, very risky, right? If your data get leaked by the other enemy countries, then you won, right? So that's the reason nowadays your HF radio, VHF radio, like there is a walkie-talkie kind of radio, and if you see the military, they use the backpack, right? Backpack communication, okay? Those kind of communication are very, very robust. Even it is able to track your signal even 1 second. You all fighter plan will be down. Because if they just change some kind of direction, change some kind of command, then you can. So this is the reason. This is the reason defense people are using heavily, and in only our group used to use in this domain for the last 15 years. Now I'm just trying to apply those codes to the defense. Okay. So I'm giving some. What is the difference? We studied three things. One is Bole complementary set. One is CCC, Bole complementary set, Bole complementary pair, mutually orthogonal Bole complementary set, CCC. You can see that they are not much different, only slight difference. What CCC? There is a three numbers matrix. Each matrix there is a two rows. What is MOGCs? MOGCs says that the number of rows is lesser than CCC. Otherwise they are same. What is GCS? Number of okay. What is the GCP? GCS, not P matrix, only one matrix. Okay. So GCS. And what is the GCP? In one matrix, only two rows. I have given some systematic picture. You can see that number of matrix is same for CCC, MOGCS, but number of rows in MOGCS lesser than CCC. GCS only one matrix, and GCP only two rows. Okay, and they have different kind of application in the different. You need to tell me because I have time. Okay, so GCPs. Now there is some kind of construction, as I said. So as I said, GBF. What kind of construction? I'm just giving few. It is a very fast task. It can in not 1 millisecond, even a few microsecond, you could be able to get this code. That fast, then the systematic construction or the computer science-based construction. So what do you do here? No, we take the variable that Boolean variables x0, x1, xm. They are nothing but a 0, 1, 0, 1, and first from there we create a monomial. What one? Like 1, x0, x1, x1, x2. So all the combination we take the monomial. Then we make some kind of Boolean function. For example, here we have given x0, x1 plus x2, x1. This is a Boolean function. Now, if we know the value of x1, x0, give some pattern, that pattern, how to give, those are the main things. Then you will be getting this GCP, GCS, CCC, all the construction can be constructed by this one. But those all we have developed after 2010 only. Before, there are not much any GBF available for that kind of construction. So I'm giving one example, then we'll be able to understand. First, we need to understand this. We relate this Boolean function to graph. Okay, so it is a special kind of Cayley-Hamilton graph. Am I right? Cayley-Hamilton graph. This is maybe I forgot the name of this function. So how to construct this graph from here? No, x0, x1 means there will be h. x0, x2 means there will be h. You can see that x4, x1 there is no h. That's why there is no term x4 into x1. So we can it is a uniquely convert from function to graph and graph to function. Now then from here we have to change this function. Boolean function graph we are saying if we delete some x1, okay, then we'll be getting different kind of. But we can delete or which kind of graph will be giving such kind of code? There is some kind of specific structure. Okay, I forgot this name. So based on this Boolean graph, we can able to get different kind of construction. So I'm giving one example how we are getting this Boolean function, and from how we are getting the code. So you can see this is a Boolean table. Boolean table, everyone know, right? We have studied in BSc. Okay, I think Modanungal sir taught this course, right? Boolean function, sir. Yeah. So this is the Boolean function. Now you take any of the function F0, F1. This value nothing but 0, 1, 0, 1. That this I0 nothing but either x0 or x1. You substitute those values. This F0. Then let's take the first row. This first row will be giving f1. Second row will be giving the f2. Third row will be giving the f3. Just substitute those values this function. So you can see that if you change the function, then you change. Okay, I have not reached to the yet construction, what kind of sequence. So, but if you understand this one, that how to calculate F0, F1, F2, then after you get this one, then we arrange F0, F1, F. This is called the Boolean function. What is the F0? This F0, then we get this F. And now, what of F0 goblin? Those value we have to put cube root of unity. Equal to 2 pi cube root unity we know. Just put F1, F0, F1. Then whatever W we are getting, that is our code. Now, if you change this function, how we can change this function? Now, then you have to come to the graphical representation. Then you have to find their following some properties. Many things are there. I'm not going to these details. Now, the thing is that let's say there are n number of code, n users. As I said, 2 to the power n limit. But now I need 2 to the power n plus 1. How I can get? If I go 2 to the power n plus 1, 2 to the power n plus 1 and 2 to the power n plus 1. Are you getting me? 2 to the power n plus 1 and 2 to the power n. So you can see that what is the difference. So for example, I'm giving, let's say you needed 17 users. Then 2 to the power 4 will be getting 16. 2 to the power 5 will be getting 32. But how? 17. 32 means I need to transmit a lot of powers. So then 17 I need. How I can get 17? So that is called some technique. It's called insertion. So if we apply some proper insertion, no, we don't have to get 2 to the power 5. We can go to the 4 plus 1, 17. Users can be supported by insertion. Let's say I need a 31. Then how we can do? No, there is a truncate. You have to do the truncation. How do the truncation? That algorithm is here. So we can do some truncation. This one and this is another kind of function that how this is a goal complementary pairs. Okay, and this is very 1999 work. Some work we have done, and these are some examples I have given. I'm giving some of our remarkable work. So this is a kind of restricted Boolean function. Restricted Boolean function you might not be knowing, but do you know that a graph is given how to delete a particular graph, then what will be the structure of the graph, like graph coloring problem. Okay, so this graph coloring problem we have represented by the Boolean function, that if you restrict some Boolean function, then some of the vertices will be deleted and some of the isolated vertices, you know the isolated vertices, right? So then based on the isolated vertices, you can able to construct different kind of codes. Okay, so these are the things. Out of time, I'm making so many slides, so I know just I want to give a little bit brief overview that what kind of work I have done till 2020. Those work 2020. Now next 5 years, I'm applying those code for the practical application of the defense. Yeah, thank you very much.
Thank you, Professor Majhi, for nice lecture. And it is the combination of mathematics, because his basic is mathematics and he's expert in electronics. So this is the ideal regarding the mathematics, application of mathematics in your communication system, particularly wireless communication system. Okay. So see that this is the example of you can use the basis, how we can use the orthogonal vectors, matrices in real applications. So if you have any question, then you can ask. 2-3 questions we can easily take from the participants. It may from the your online participants also, and from the offline participants. So first I'm asking from the offline participants if you have any questions or any suggestions. Any question?
So, I'm from pure mathematics background. So, I now want to ask you one thing. You mentioned that if we try to find thousand vectors or more than thousand vectors which are orthogonal to each other, but if we solve it through applying linear algebra and we consider r1000 or Rn, where n is greater than 1000, and we consider the standard order basis, where epsilon 1, epsilon 2, this kind of thing, where the ith vector actually has the ith coordinate 1 and other coordinates are 0. So maybe I understood it in a wrong way, but we can find. So what you I actually found difficult.
R means ring.
No, no, R for real one. Okay. Rn, okay, n-dimensional vector space. So in n-dimensional vector space, we can find the standard basis. But were you talking about this or some random one? Okay.
No, standard one means 1, 0, 0. Then what will be the length? What will be the length?
One.
No, what will be the length? Length will be your 1000 vector. Then 1000 length will be there, right?
Okay, 1000 coordinates are there. Okay.
Coordinate.
Okay.
But I need a vector, maybe 100 or 200 vectors. I have to find this orthogonality 1000 people. I cannot increase means there is a complexity involved. Okay. Increasing means there is a complexity involved. Our goal is to even usually not 1, 0, 0. We here 1, -1, 1, -1. Okay. Our main goal is to minimize the length. Then you find the maximizing the number of users, number of orthogonality. That was the main. Although I am saying the orthogonality, I am my main objective to find the cross correlation and cross linear. We are interchangeably change those words. Our main goal is to correlation and cross correlation. Correlation has to be high, cross correlation has to be 0. Not R3. I'm vector. I'm talking about vectors. Just think about vectors. In the communication, nothing but a vector. All image we transmit to 0, 1, 0, 1. The length of 0, 1 could be anything. 1000, 2000. There is not an issue. R3. No, it's not R3. Number of users. Yes.
So any question from offline participants? And any question from offline participants? So since there, so I thanks Professor Majhi for his nice and your real action of mathematics lecture. So thank you once again.
Please call me once.
Okay. So with this lecture, now we are going to lunch, and the next session will start at 2:30 p.m. Okay.
Itu lain semua. Terus dia terus keluar lagi gitu.